So it is the average distance between each data value and the mean. So facts and characteristics, sometimes we can call it MAD. And the other thing is it tells us, oops, it tells us how exact or how precise our data is. I was looking at how to say that here. It tells us really how much our data varies. That's a good way to say it. So we're not going to do a whole example in the example thing here because the mean absolute deviation is kind of quite a process to go through to get that. So instead what we're going to do is we're going to talk about what does that number mean. And so the closer the MAD is to 0, the less the data varies. So the closer the MAD is to 0, the less the data varies. So if we talk about our student that either had A's or F's, okay, and we did a mean absolute deviation on their grade, we might find that their grade varies by 20 points away from the average. The average is a 7, let's say a 75 is the average C, but they sometimes have 95s and they sometimes have 55s, so their MAD might vary by 20, where you might have another student who's a C student, but they usually do get within that C range. Maybe they just get a couple higher or a couple lower than a 75, and so their MAD is only like 1 or 2. And so that tells us that that person who's only has a mean absolute deviation of a 1 or 2 more consistently gets C's. The other person who's getting A's or F's, they've got this big, huge range that they seem to be scoring in between, and it's averaging out to a C, but it isn't really a good reflection of what their grade is. If I was going to look at that person who got C's, I might say, you know what, math's a struggle for them. They almost always get C's. If I look at that person who's either getting A's and F's, I'm going to have to dig a little bit deeper into them. Because sometimes they're getting A's on things. Are they getting A's on quizzes and tests and F's on homework because they're not doing that? You know, that tells me a little bit of information there on what's going on, as opposed to somebody who would like maybe always get a C. So non-examples of mean absolute deviation really would just be the important thing here. And again, we're going to write instead of showing an example, we're going to write something. Something that people forget to do is oops, I shouldn't write it that way. I should write not taking absolute values of the difference. So we're just going to write that down right now, and that might not even make sense to you right now, and we'll come back and look at that and talk about what that means in just a second. So since we're not actually putting an example here, we're just kind of talking about it in general terms, I don't want you to file this away yet, because we were going to want to come back to that and talk in a little bit more detail about what that means so that we can see what we're looking at there. So, going back to this page, this is how we would find a mean absolute deviation. The first thing that we would need to do, piece of paper right this time. the first thing that we would have to do is we are going to find the average of the data. So if we think about our problem that we did yesterday with our pets, we found that the average was 6 pets. So if we were going to find the mean absolute deviation of the data we collected yesterday, we've already done the first step, which is just to find the average. The second step then, though, is to find the difference between the average and each piece of data So we want to find the difference, but the important thing here is we want to take the absolute value of the difference. So remember, when we talk about the distance, how far is something from 0, for example, we said it has to be a positive number. Because no matter how far I walk away from Xavier, and no matter what direction, I'm always a positive distance away from him. I can't somehow like get a negative 2 feet away from Xavier. Like, I don't know how I would do that. Because we'd always measure this as distance is always a positive number. So we would want to take, if we're talking about how far away is each number from our average, we would always take it as a positive number because we're talking about distance. So I'm just going to write this off to the side here beside where we've done that. So I knew that my average of my data yesterday was 6, right? Is that what we just said? Okay, so my average was 6. So my data that I had collected, I've got it right here, it was 1, 2, 3, 3, 5, 6, and 20. So what I want to do is I want to find the difference between each of those pieces of data and what my average was, which was 6. So I'm going to subtract 6 from each of those pieces of data. Do it right on that same page. So 1 minus 6 is negative 5. 2 minus 6 is negative 4. 3 minus 6 is negative 3. I had another negative 3. 5 minus 6 is negative 1. 6 minus 6 is 0. And 20 minus 6 was a positive 14. So I've found the differences, but then I also want the absolute value of each of those differences. I want to know how far away are each of those distances from 6. So I get 5 and 4 and 3 and 3 and 1. Oops, 1. And then I get 0 and 14. I'm finding distance between. I'm not finding range.
I meant distance.
So they all have to be positive. Okay, so now I know how far away each piece of data I collected was from that average of 6. So then my next step then that I need to do is I'm going to find the averages, or find the average of the distance. Or of the distances. There we go. Find the average of the distance. So we know how we find average. We add them all together and then we divide by the number of numbers. So I'm going to add up all my differences. So 5 plus 4 plus 3 plus 3 plus 1 plus 14 is 30. Make sure I'm right there. Yep, 30. And then I had 1, 2, 3, 4, 5, 6, 7 pieces of data. So I'm going to divide that by 7. And 30 divided by 7 is about, I get 4.28. So again, I'm just going to round it to 4 here. And again, we could actually go ahead and do like 4.3 because we're not necessarily talking about animals anymore. We're talking about how consistent is our data. So it kind of gives us an idea. If you left it at 4, I would have been fine with that. The only thing we have to watch is sometimes our differences might be really low, like less than 1, and really close to 0. So we don't want to just say it's 0 if it's not 0, because 0 would mean it's right on. So then the last thing that we're going to do is looking at it, and this is what we talked about before, is that the closer it is to 0, so the closer to 0, the less the data varied. So I'm not very close to 0. I'm at 4.3. So even though our average was 6, what that 4.3 means is that in general, we probably were somewhere within 4 of that 6 as our average. So it tells us there was a lot of variety there in our answers. We didn't have everything that was just right there next to our average. Now, part of our problem on this one is that we had that big outlier. If we had found the average without that outlier in there, and we were, our average would have been lower, our average probably would have been maybe in the 3s or something like that, then our variation would have changed too. We wouldn't have had that huge variation there. So going back to our Freyer model for just a second here, we talked about the closer it is to 0, the less the data varies. And then also, if we don't take the absolute value of the differences, that's going to change our answer a lot. Because if we didn't take the absolute value, if we just added together -5 plus -4 plus -3 plus -3 plus -1 plus 0 plus 14, I only got a difference of 2 then. Because some positives and some negatives cancel each other out. And so then if I would take 2 and divide it by 7, it would look like, oh wow, look at, we had a really low variation. It was 0 point something. But it's because some of those negatives and some of those positives canceled each other out to make it look like all of our numbers were a lot closer to what the average should have been. Okay, so on this one here, we've got, this goes right along, we've got boys basketball tryouts coming out here, and we've got an example here of some data that they kept on some basketball players. So it says that the coach noticed that the means and medians for both players are the same. So the first thing it's asking us to do is find the mean and the median for both players. So go ahead with your group. Again, notice this chart means that Terry got 9 and 9 and 9 and 9, and then he got 10 and 10 and 10. So you have 8 pieces of data on here. Chris was kind of more all over the place. He went up to 15, but some games he only got 2. So, so you're going to go ahead and with your group find the mean and the median of those 2 people's scores. So, looks like most of you got that far pretty well. That we were doing the average here, and so you had taken the, added them all up. If you added all those up, you should have got 76 divided by 8, which was about 9.5. Here, if you did the median, you would have had 9 and 10 in the middle, so that's 19 divided by 2, which is 9.5. Again, same thing down here. If you add all those up, you got 76 divided by 8. If you found the median, you would have ended up with 8 and 11 in the middle, and you would have gotten 9.5.
Average and the mean are the same thing. No?
The median, I'm sorry, median. Thank you. All right. Okay, so it says, can you find the mean? The basketball coach had already said he noticed they were the same for both players. So we know that the mean is 9.5. Now again, we're talking about baskets. So we could leave it at 9.5, but we could have rounded it up to 10 thinking that I can't get half a basket very easily. But if we're going to go ahead and leave it at 9.5 just to have some practice dealing with decimals here. Oops, I can't spell median. There we go. All right, so it says, do you think that Chris and Terry performed equally well during the first 8 games of the season? So what do you think looking at these graphs? Do you think they scored the same equally as well? Okay. So again, that was kind of just an opinion, like looking at that. I mean, Chris scored more points sometimes. He scored less points sometimes. Terry was more scoring right in the middle there, but he never went higher than 10. So what do we know about the difference between those 2 players? What do you think the difference is?
They scored in different times. 0.
Okay, they score a little bit differently, but what do you think the difference is between these 2 players? Jack?
0.
What do you mean 0? There's 0 difference? They're definitely playing different games here, right? Their charts don't look exactly the same. What do we think? We're focusing on question 3 here, guys.
Oh, I know.
What is the difference between the way these 2 players are playing? What do you think?
The variety.
The variety. Shh, stay with your group. Okay, what is the difference is the amount they vary. Terry seems to be very consistent. He almost every single game scored at least 9, but he didn't get higher than 10. Where Chris was a little bit more all over the place. Some days it seemed like he had really great games where he scored 15 baskets. Other games he did games where he only scored 2. So Chris had much more variety in the baskets that he shot than Terry. So it says calculate the mean absolute deviation for both players. So this is where I flip this over, do this on the back. You're not going to be able to cram it into right there. Let's first do Terry. Terry had 9 and 9 and 9 and 9, and then he had 10 and 10 and 10 and 10. The average was a 9.5, so we want to subtract 9.5 from each of those scores. So 9 minus 9.5 is negative 0.5. So each of these is going to be negative 0.5. And then 10 minus 9.5 is positive 0.5. But then, remember, we have to take the absolute values of all of these. So the 9s were only 0.5 away from the average, and the 10s were also 0.5 away from the average. So we found the average, we found the difference between the average and each piece of data, and we took the absolute value of that. So my next step is I have to find the averages of those distances. Well, this should really be pretty easy. We're going to have 4 divided by 8, and our average is going to be 0.5. That per game, he only really varied by half a point, positive or negatively. That he was very close to 0. With your group, go ahead and do the same thing for Chris's baskets. How consistent was Chris? So let's take a look at this, because a lot of you were almost there or close to there. So again, we had to take, this is not a fast, quick thing. We had to take each number and subtract it from the average of 9.5. Some of those were going to be positive, some of those were going to be negative, but again, we want to know on average how far away were we from what the average was. So here's all my distances from the average, and then when I add all of those up, I got
35.
should have gotten 30. So when I add all of these up, because my next step here was I had to find the average of the distances. So 30 divided by 8 gave me 3.75. So Chris, even though they both had the same average, Chris's baskets varied by about 3 per game, meaning they should have been about 9.5. Sometimes he was almost 3 higher than 9.5. Sometimes he was almost 3 lower than 9.5. So Terry's deviation was only 0.5, where Chris's was 3.75. So it says, what is Terry's mean absolute deviation, where he said it's 0.5. It's closer to 0.
How much minutes do we have left?
So what does that mean? What does it mean that Terry's mean absolute deviation is closer to 0? What does that mean for Terry? Yep.
It means that he has less numbers that are varying.
Okay, he's a more consistent player. So Terry is more consistent in his scoring. There's a lot. Even though they both have the same average, Terry consistently scores in that same range every time. I can count on Terry to probably make between 9 or 10 baskets per game. In Chris's absolute mean deviation, we know it's higher than Terry's. And so what does that mean? And that means that Chris is less consistent. Meaning if I want somebody who's going to go out there and I'm hoping that I'm going to get 8 points out of this person per game or 8 baskets out of this person per game, sometimes Chris might be awesome and he's going to give me 15 baskets, but there's almost as much chance that he might not be as consistent and he might only give 2 baskets. So this is actually a real scenario that a few years ago, if that they